Good morning. Since everyone seems to be replotting their Chia plots to make them work with the new pools, I figured that I might share my findings from playing around with the MadMax plotter and actually achieving sub 20-minute plots. Now, every system is unique, and just because I got sub 20 with my old plotter doesn't mean that you'll be able to with yours. I will, however, show that I started out with more than 2200 seconds and had a personal best of 1102 seconds with my specific system, actually cutting the plotting time in half simply by tweaking settings, changing file systems, and so forth. I will be talking about how big an effect each change had to my system, and while you won't get the exact same effect, because every system is unique, it might still help you lower your total time per plot. At the very least, this can serve as a checklist for you to test out different plotter settings, file systems, operating systems, whether to rate or not, etc. I started my journey with a fresh install of Ubuntu, a Ryzen 9 5950X with 128 gigs of CL18 3600 RAM, one terabyte Samsung 980 Pro for the OS, and two terabyte 980 Pros for plotting, with destination SAS drives connected to an HBA, which allowed me to quickly remove a drive and walk it over to my farmer. And I highly advise everyone to have the farmer and plotter separate. This way, if you need to restart the farmer due to some issue, you'll be able to do so without having to kill the plots that are in the process of being plotted. Potentially even more important is that while you're playing around with different settings on your plotter, you won't have to worry about losing any potential winnings from already plotted plots. If you cause your plotter to crash, your farmer won't know about it. In fact, if you want to, you can completely disconnect your plotter from your home network once you're done installing MadMax. So let's just take a quick look at the command itself to plot with MadMax plotter, and the options here. The N option obviously is just plotting a single one. So R, the thread value, it doesn't really seem to have an effect on my plots. I haven't tried the newest MadMax plotter, the newest version of it, but with the previous version, I just set mine to the max possible for my system, and even if I changed, it was still pretty much the same. So I just set mine to 32 because that was the max on my my old system. U, the bucket size. So you can either write 9 or 512 is the same thing, because 9 is actually 2 to the power of 9. You can write 8 for 256. You can write 7 for 128. So it does have an effect on the time that it takes to plot, and whether or not it's faster, which one is faster for your system, it will vary. For me, it was 256 and 512 were the fastest. But more importantly, if you are short on memory, another thing that the bucket size does is the more buckets, the less memory required. So this is particularly important if you are planning on using your RAM as the T2 temporary storage, especially if you only have 128 gigs total. If you have plenty of RAM but not enough for plotting to RAM, or if you have terabytes of RAM and just don't care about memory, just go for whichever bucket is the fastest. So T is the actual the temporary director, which will be, in my case, I used NVMe's. You need at least 220 gigabits for that, and you want it to be reasonably fast. So 2, that would be the T2 memory, the temporary storage, where you will be doing 75% of your writes. And if you can do this in RAM, do it. Even if it doesn't give you a speed boost, I would still do it if I were you, because you're going to spare your NVMEs by taking 75% of the writes off of them. And even if you don't use RAM for the T2, make sure that you stress test the RAM, because if you don't, you will get core dumps or worse. But especially if you do use RAM for T2, the MadMax plotter actually found errors that memtest didn't find when I was plotting to my RAM disk. So D is your final destination. Just make sure it's a big, cheap spinning drive. Unless if you're using a script to move things afterwards, then you can tell the plotter to leave it at the T location by not having D, which would make the copy file stage after you're done plotting take 0 seconds, because it would simply rename the temp file to .plot. I wrote a script where I do every other plot on a different T, on a different NVMe, and then it transfers to two different Ds as well. That way the copying doesn't affect the plotting at all. So useful commands if you're doing this in Linux and you're new to Linux. If you want to use a RAM disk, RAM drive, if you want to use RAM to write on, you need to create a directory for it first. In my case, I created one under /media/r. Then you mount the RAM as a tmpfs. Another good command to use, if you're manually overclocking. If you're not manually overclocking and you're in Linux, I believe the default setting for the CPU frequency is on-demand mode. So by using this command, you're running a for loop for every single thread that you have. So in my case, I used a 5950, so I had 32 threads. So you start counting at 0, so it goes from 0 to 31. So I individually set every single one to performance mode instead of on-demand mode. So another thing you want to make sure that you do is turn swap off. If you start swapping, you're gonna see you're gonna be hemorrhaging time. Don't do it. And worst thing that can happen is if you're trying to do a 110 RAM disk and you run out of RAM, you're gonna crash. But at least you'll know that you can't do it, or at least not in that particular way. You may have to tweak some settings or whatever. You can probably make it work still. You just have to tweak your system, but turn swap off. Just do it. This is how you turn off journaling. Now, journaling did have a tiny effect. It did improve speeds just a little bit on the NVMEs or whatever you're using as T. It wasn't a game changer, but you might as well just run a command to turn off journaling and just get a few seconds extra. Here's a command to create, in this case this is a second NVMe, to create an ext4 partition labeled 1 with a cluster size of 256 megabytes. If you do cluster size of 256, make sure that you use the option bigalloc. Otherwise it won't work. Also at the same time, remove the journal while you're doing this, because otherwise, at least I had issues if I didn't immediately remove the journal when it tried to create the journal for it. So just remove it while you're partitioning it. Here's a command for making an XFS partition. If you are wondering what options exist, if you want to play around yourself, maybe find something that I haven't found, in Linux, you can use the man command essentially type man followed by the command to see all the options for that command in Linux. It's really, really useful. So to the actual results, I actually started out here with I didn't have them rated then, just a single 980 Pro. This is all in Linux. So I had a single 980 Pro and used a RAM disk. Again, this we can just ignore because it just doesn't matter. I started with bucket size of 128, and I got a lovely score of 2269. That would equate to 38 plots per day. Not exactly what I was hoping for with such a less than cheap system. I changed the bucket size to 256 and got slightly better. The thing that really changed it for me was changing from NTFS to ext4. As y'all can see, we're talking 900 seconds. Almost cutting in half. I mean, that was just that was just insane. Plus, this is actually without a RAM disk. It's a single NVMe, no RAM disk. Meaning this is actually, if you were to just ignore all the extras that I bought, it was actually the cheapest system. So just checking the dollars, the total amount, the cost of the system, and dividing it by plot per day, it was the cheapest out of all of these systems. Obviously, you can go cheaper by going with, say, 5900. They're a lot cheaper per what you get for, you know, the CPU. But that's a different discussion. Moving on, I rated the same drives, and I did see an improvement. Not as much as I'd hoped for, but still 90 seconds. Adding the RAM disk was, again, you see an improvement, but it's not really that much. And here I changed the bucket size to 512, got 1140. It just goes to show that you don't, while you can do every single individual thing to make things quicker, you may not have to do all of them because they are very costly. Once I was done playing around here, I actually went over to Windows. I got a whooping 2,500 seconds here. Now, changing to 2 megabyte cluster size, I actually dropped it down by 1,000 seconds. So if you are using Windows, I would definitely recommend doing 2 megabyte cluster size on your NTFS. Or for that matter, I actually did not see that big of a difference between NTFS and XFAT if you set it to max. I also didn't see that big of a difference. So in Linux, XFS was slightly faster than the ext4, and ext4 was slightly faster than the XFAT, and it was just incredible amounts faster than NTFS. If you plan on using your computer for both Windows and Linux, and you don't want to reformat everything every time you swap from one to the other, you may actually want to consider trying out XFAT if it works for your specific needs. Just make sure that you go for the max cluster size. I believe that it's 32 megabytes for XFAT, something like that. It's more anyway. So overall, my absolutely best in Windows was, I have it written down somewhere, but I can't find it right now. It's 1,440 something seconds. This was with using CTR for the overclock since it is a Ryzen. Using 110 gigs of RAM for T2 and NTFS rated and a 2 megabyte cluster size on the NVMe's. My absolute best for Linux was 1102 seconds. That was with manually overclocking all the cores to 4.7 gigahertz. And the obviously RAM disk and XFS RAID. I wouldn't recommend XFS RAID because a lot of people seem to have had issues with XFS RAIDs with crashes. I only ran it a couple times, so I didn't crash, but just be warned. It may not be for you. And again, you may just want to try a single drive because RAIDs don't really do that much. Either way, this was my personal record. I think I hit about 75 centigrade. So for fastest continuous runs, obviously, because all the other runs were the first run of a series or just a solo run. So for continuous runs, the best I got was that setup with a 4.7, and I got between 1102 and 1150s in time. So it did change a little bit between each and every plot. Each and every plot is unique, but still I didn't go above 1200. Didn't go above 20 minutes at all, and I think I did 36 in series without crashing, without anything like that, and without going below 1150 or above 1150. So I did try a different setting because I didn't quite. I wanted to try something that would be the least impactful for my equipment. So I tried without OC and the alternating NVMe's and also alternating final directories. Actually, through a script, not in the program, not in the MadMax plotter. And I got between 1150 and 1250, averaged about 1200. So essentially, averaged 20 minutes without any kind of overclocking on it. So you don't have to destroy your system if you don't want to. Yeah, all in all, I mean, in conclusion, unless you're planning on plotting 24/7 for a year or more, it really isn't worth it to go all out if purchasing a system simply for plotting. If you want a specific system for some other purpose, you should of course buy what you want and possibly just look at my results as a sort of cheat sheet to whether or not it's really worth it for you to get that much RAM, or if you really need 2 NVMe's or not. As can be seen by my results, the biggest changes were accomplished not by adding more RAM or using RAID, but simply by changing the file system of the T directory, both in Windows and Linux. I will be running a few tests on my new plotter, which I plan on building later today. If anyone has any suggestions on what they would like to see me test, feel free to leave a message in the comments section below. Thank you.